Okay, and it's half past, so I guess I'll go ahead and get started. Mark, I assume you'll be watching the chat and YouTube for questions. And thanks everyone for having me here. The day's been excellent. I hope everybody else has been enjoying it as much as I have. As you can see, I'm Will Marchant. I work for the Space Sciences Laboratory, which is at the University of California in Berkeley. I actually live in Virginia on the East Coast of the United States and telecommute full time. So the lab was established at the beginning of the space age, and we mostly support science for the faculty on campus. And that's balloon payloads, sounding rockets, and then most of my involvement is in satellites, low Earth orbit. We've got some missions going out as far as the moon. We've got a couple of payloads in orbit around Mars now. And we've got a couple of payloads on Parker Solar Probe, which is a pretty exciting mission that's diving down into the outermost layers of the sun and making in situ measurements. So pretty amazing stuff. You may have heard of Space Sciences Lab without knowing about it. We're the home of SETI at Home, which is a citizen science program where your screensaver would crunch data from radio telescopes looking for extraterrestrial intelligence. And then Stardust at Home is a program where plates of aerogel were sent out to a stream of dust that we know is coming from outside the solar system out near Jupiter. Those were returned to Earth, and we built a robotic microscope to scan those. But you can sign up at Stardust at Home to be trained to look for the actual dust particles and identify those. So that's pretty exciting. My background is in computer science, although I've got a master's degree in space studies, distance learning program from University of North Dakota. And I'm working on a few different missions now. New Star and Icon were both launched on board a Pegasus rocket. New Star in 2012 and Icon a year ago today, actually. So it's kind of cool for me to be doing this talk on the anniversary of our finally successful launch. You can ask about EOI and MOAB and tracers later if we have time. I'm going to try and push on through. So Berkeley has a fairly large space program. A lot of these missions are currently operating. Icon, as I said, just a year ago got launched, and we're controlling that. That's wholly a Berkeley operated mission out of our Mission Operations Center from our ground station at Berkeley and a few other ground stations around the world. We do have an 11-meter dish that we can use to talk the missions out as far as the moon. And so we're controlling a couple of LEO missions as well with that. But I'm going to talk a little bit more about the Icon program because that was the most recent one that I did. This is the spacecraft. It's nadir pointing because it's space weather stuff. People can ask about the science instruments later if you're interested. But Icon is interested in this layer of atmosphere at the interface between what we think of as our shirt sleeve environment and the much higher atmosphere that the International Space Station, for instance, is flying through. This is interesting because radio signals like GPS have to go through it. And so this affects some navigation signals and also long-distance communications. So understanding how terrestrial weather affects this layer and then how space weather, mostly from our sun, affects this layer is vitally important for a lot of day-to-day activities. So originally, Icon was supposed to launch from Kwajalein in the Marshall Islands. And we'll talk a little bit later. We actually ended up launching out of Florida. But I travel a lot because in the later stages of our missions, I usually end up being the mission operations person on site at the launch site. And so I end up operating the spacecraft. Kwajalein is a long ways from anywhere. So you have to be completely prepared when you go down there. To get there, there's an airplane from Honolulu that flies down all the island chains on one day flies back the island chains the next day. That happens 3 times during the week, and then there's one day during the week when there are no departures or arrivals. You can scramble military aircraft out of Honolulu, but it's incredibly expensive. And rocket science is difficult, and it can occasionally be dangerous. I didn't really understand how dangerous it was until I went to Kwajalein for my first time in 2012 for the New Star launch, and found out that there are inimical life forms on board the island. So I escaped both my launch campaigns to Kwajalein without any new scars. So but it was close at times. So just a little bit about the Pegasus launch vehicle, because I think it's so cool. And what's not cool about rockets and airplanes? So Pegasus first started flying in the early 1990s. It's the first privately developed launch program completely paid for by Orbital Sciences. It's the first one with a reusable first stage. So this L1011 TriStar aircraft obviously comes back and can be used for subsequent launches. There have been over 40 Pegasus launches so far. If you're lucky enough to visit the Smithsonian facilities here in Northern Virginia, that's called the Udvar Hazy Center. It's where the Smithsonian Institute stores all their large exhibits. There is a Pegasus XL round there, so you can actually walk on both sides and get an up-close view of this pretty amazing vehicle. It's a 3-stage rocket. These are all solid propellant, and so it comes from the factory fueled, and the flight profile is that the L1011 aircraft goes up to about 40,000 feet, and the rocket is dropped off. And then the flight profile up into orbit about 10 minutes later is completely autonomous. So that's completely controlled by the Pegasus vehicle itself. So this is me at Vandenberg Air Force Base working on the integration of the spacecraft into the launch vehicle, and that happens at Vandenberg. And back here, you'll see right down there are the computers that I'm responsible for. That's a small copy of the Mission Operations Center that allows me to turn on and check out the spacecraft and get it ready for launch. And then in the event of a launch scrub, to safely turn the spacecraft back off again so we can get ready for the next launch attempt. It's pretty exciting working in here because that vehicle is fully fueled at this point. So there's about 40,000 pounds of low explosive in there, propellant. And so you want to be really, really careful that you don't actually set that off, because then it's a bad day. So RF emitting devices, your car key fobs or cell phones are not allowed inside this facility. And so just doing some routine operations like basic calculations can be difficult because we're so used to pulling our cell phone out to do basic math. And so that's some place where I found having a dedicated calculator that I could carry with me really sort of shone. And so, yes, my faithful DM16 accompanied me throughout the entire ICON campaign. Here's that Mission Operations Center on board the L1011 aircraft. So I get to set this thing up, and the power supplies that run the spacecraft are actually in this rack that stays active during the captive carry flight when the rocket is carried up to altitude for launch. I do the turn on the spacecraft, run all the tests, and get it ready to go. And then this equipment has to be disabled and stowed ready for the flight portion of the campaign. And with all the traveling I do, of course, I've got sorry, I'll apologize to the HP crowd here, but I couldn't resist showing this TI programmer that I've had since the 80s, and my original 16C from the 1980s that these are still working. But frankly, with the amount of traveling that I do, I'm just not willing to risk these things in my backpack. going to Kennedy Space Center, Cape Canaveral Air Force Station, Florida is where we ended up launching. We did a lot of instrument spacecraft integration in Arizona and in Utah, Vandenberg Air Force Base, where the launch vehicle is assembled, and then you have to fly through Honolulu, stay overnight before you can fly down to Kwajalein, and then you have to come back again. So lots of miles. I'm not willing to risk my my heritage equipment on that. But that's when the Swiss Micros machines are just awesome. So the DM16 is a perfect size to fit in your pocket, along with a few other basic tools, and that's critical for what I do. When that rocket's on the L1011 aircraft, that's all a hazardous package, and so it's usually um, uh, it's out in a part of facilities where if there is an incident, it will be safe. And so at Cape Canaveral Air Force Station, that's the skid strip, which is the runway on the Air Force Base. At Vandenberg Air Force Base and at Kwajalein, it's a place called the hot pad, where you keep aircraft that have armaments or are anyway hazardous. The problem with that is that you usually have to walk out to those facilities. So you park, and then there's a quarter-mile to a half-mile walk, because you can't take vehicles out there because you worry about debris getting left on the runway that can get ingested into engines. And so every little thing that you have to carry, Kwajalein, mid 90-degree temperatures, mid 90 degree humidity, you really start to feel that. And so you don't want to carry a lot of stuff. But on the other hand, you need a set of basic tools with you in case there are some issues. And so Victorinox makes these really cool cyber tools that have removable bit drivers and a light and a little set of pliers. Those are awesome for lightweight jobs. If you need a little bit more length, then I have a screwdriver with removable bits that'll do that. And then this Leatherman Crunch is really cool. This is a set of vice grip locking pliers. So when you need something with a little more heft, you can use that instead of the pliers in the Victorinox. And of course, you need your calculator, your DM16 in this case, for the intellectual muscle power that is that's required. So here's the mission operation system as it gets packed up to get ready for the actual launch flight. We turn the spacecraft on. It's usually about 6 hours before the aircraft lifts off, and we spend about 4 hours configuring it, charging up the batteries, and making sure everything's okay. And then there's a huge rush to pack this equipment up and get off the airplane before they can start the engines. So there's this tension where you want to be controlling the spacecraft as late in the flow as possible, but you don't want to get yelled at by the crew chief when they're trying to get ready to spool up the engines and get onto the launch campaign. So getting from fully operational to this packed state is always fraught with peril and terror. And one of the things is that each one of these boxes has got 2 lids, and each of these lids has got 6 of these little clasps to hold it shut. And it's just typical that somebody, and it's never me, I never do this. You're supposed to fold these things down before you slide the covers around. And unfortunately, if you don't do that, 2 people moving these racks around, they weigh about 100 pounds each. You'll just jam these connectors up, and then you can't close these lids and get ready for the actual takeoff. So you need that Leatherman Crunch at that point to get this thing bent back so that you can get the lids fastened on. But eventually you get ready, and the observatory's in the nose of the rocket. It's all powered up. It's ready to go. And at that point, you hand things over to the flight crew, who are going to take the aircraft off and hopefully fly your baby into space. And then there's the long walk back from the aircraft to get to your car, so that you can head over to the local launch control facility to sit on consoles so that you're monitoring during the climb out and during the launch phase, you hope. We had a handful of false alarms on the Icon campaign where the rocket had to come back and land. This photo is actually from one of those. You can see it's dawn in Florida, where we're dragging ourselves out to the aircraft again to reset all the equipment up so that we can talk to the spacecraft and safely turn it off to get ready. So that's a very long process, and you're very tired because that's at the end of a very long day. But eventually, the rocket flies, and we've been lucky so far. We've gotten both New Star and Icon into orbit, and they've been working perfectly. Icon just, as I said, celebrated its birthday and with lots of good science results. So if you're interested in contacting me, feel free to go to that URL. If you want to learn some more about Icon, you can go to the official NASA site. If you go to the Icon site, there are lots of photos and videos if you like rocket stuff. And I recommend the Wikipedia article on air launch to orbit because there's a rich history. Pegasus is still an operational program, over 40 launches. There were a few other air launch to orbit efforts. And then we've all got our fingers crossed that Virgin Orbit is successful in their attempts to get onto orbit, hopefully later this year. And so with that, I will stop sharing my screen. And I will see if there are any questions.
Thanks, Will. That was great. Anybody got any questions for Will?
I go ahead.
You get to keep all
I'm just curious why the 16. The 6. What led to 16 being the best calculator to use in this application?
Yeah, of course, that's a really difficult question because so many of the HP calculators shine in different ways. The 16 is my favorite because of the easy access to all the binary functions. And it's often the case, for example, there are some communication streams that we have to talk to that have sync byte patterns in them. And those byte patterns can be inverted or they can be shifted by a few bits. And so having the 16 functions where you can rapidly do bit pattern manipulations, both as binary and hexadecimal, is really critical when you're exhausted at the end of a long day and something is not working and you're just trying to figure out what's going on. Trying to do that stuff in your head is really difficult. A lot of the calculations that we do kind of rapidly are based on things like how long is it going to take to discharge the battery to a safe level so we can turn everything off? How long is it going to take that temperature that you see increasing to reach one of the yellow limits and cause an issue? So it's not a lot of it's not really fancy math, but it's stuff that's when you're tired and under stress, you really want to have a calculator that works well, because you don't want to add any extra stress to the situation because you're already at terror's edge.
So Will,
anything else?
I just wanted to say hi, neighbor, because I think you're down the road from me. I'm in Leesburg.
Oh, hey, Don. Yeah, I'm over in Winchester. So,
Cool.
Yeah, so Don, of course, Northrop Grumman Corporation is who does the Pegasus is over in just north of Dulles Airport, just a few miles from him and from me. I'm about an hour away, actually.
Yeah, it's really cool driving down the road there and seeing warp drive signs. They're all
Yeah,
Warcraft.
they're a bunch of they're a bunch of science fiction. So they had their road off of the freeway. A lot of streets in Virginia are something drive, and so they got terribly clever and did warp drive, and so yeah, that's pretty cool. They were they put in a planning process actually to take they bought an L1011 for spare parts, and they wanted to mount it on a pedestal next to their business campus there so that you could see it from the street. And if you can Google that, and you can find the planning application. I don't think anything ever came of it, but it would be some amazing eye candy.
Well, I'm definitely going to Udvar-Hazy and seeing that Pegasus now. Thanks for mentioning that.
Yeah, and I'll put in that it's in the space wing there, and the other thing that's there is the space shuttle Discovery, the actual Discovery itself. And I've got a soft spot in my heart for Discovery because that's the only orbiter I've ever actually been in. We were flying Orpheus spas, and if you see the IMAX film Destiny in Space that's narrated by Leonard Nimoy, I recommend that. So I got to go and do some satellite servicing when Orpheus Spas was on the launch pad in Discovery, and so I have a soft spot for Discovery.
Cool, thanks.
Martin, did you have a question?
I was just wondering, do you always use SI units in America?
That is an excellent question, and I just this week gave a talk to my wife, some class on how do you try and do space projects and avoid failures and things. And one of the poster children for how not to do it is the Mars Climate Orbiter from last decade. I see a lot of heads nodding, where one team used metric units and the other team used imperial units, and the end result was that the mission ended up crashing into Mars. So it's basically the project manager gets to choose what they will use. And so on the missions I've worked on, there has been a mishmash of imperial and metric stuff, and people just sit down and try and you try and pick what makes sense in terms of being able to get tooling and parts versus, and it's especially difficult when you do international programs. So on ICON, we had an instrument that we ended up doing a lot of calibration operations on over in Belgium. And so you did have to be careful to make sure that everybody was speaking the same unit language there. So it's not easy, and it's still an issue. I recommend going to the Wikipedia article on metrification, because there's a bunch of interesting stuff there. And I didn't realize that in Canada, for example, there seems to be they seem to be falling away from metric and going back to imperial units in a lot of cases. So this still seems like, after 40 years, a highly dynamic. Yeah, I don't know what to say. I'm apologizing.
Is the spacecraft dead until it comes out of its shroud and announces itself to you?
Yeah, no, that's a great question, Martin. No. So the way it works is that there are things that you don't want the spacecraft to do. You have to test the spacecraft when it's on the launch vehicle and it's inside that shroud. But there are things that you really, really, really don't want it to do, like you don't want it to deploy its solar arrays inside the shroud, because that would be embarrassing, and you would look foolish. You don't want it to turn on its radio transmitter, for example. So typically what you do is you have enable plugs that you put in as close to launch as possible. And so on launch day, there's an operation where you pull a cover off of the side of the fairing, and somebody goes in and they actually screw in these plugs that will enable the radio transmitter and enable the solar arrays and stuff. And then you cover that cover back up again. And you take a photo of those and you send that off site and you get somebody else to look at it to make sure that you didn't put in a test plug, for example, because that would be another embarrassing thing to have done. But then there are sensors in between the spacecraft and the final stage of the launch vehicle, and the spacecraft stays. It won't do certain operations until it detects that you've separated from the final stage of the rocket. So when I disconnect, when I turn off my ground system and we pack it up, at that point, there's telemetry, a subset of telemetry coming from the spacecraft through a hard line into the Pegasus rocket, and it's going out over a radio transmitter along with all the telemetry from the Pegasus rocket. And so during the carry phase, and then during the 10 minutes when we're getting onto orbit, we do see a subset of the spacecraft telemetry. Some voltages and some currents and some temperatures and things like that, a little bit of attitude information, but it's really a subset. But yeah, once that third stage and the spacecraft separate, and then the spacecraft transmitters turn on, and then there's a 1 or 2 minute time before you can get a signal acquired with either your ground station or with the TDRS satellites up in geostationary. That's pretty terrifying as well. Because at that point, if there's a really bad problem, then it's going to be a really bad day. And then the next 15 or 20 minutes are pretty terrifying as well, because that's when the solar arrays are getting deployed. Because if the solar arrays hang up, then you're going to die after a couple hours when you run out of battery power. So our spacecraft, Icon and New Star, yeah, they both had power. The computer was actually running during the aircraft flight and during that 10-minute launch onto orbit. We've got 3 more minutes if there are any other questions. And I put some URLs into the chat if people want to go to the websites to look at some stuff.
I also have a question, if I can ask one. Is the DM16, does that have to be certified for you to be using that Nero rocket?
That's a great question, Mark. No. So basically, what you have to do is you have to go to the ground crew lead and tell that person, what equipment you're bringing into the area, and you have to assure that person that it's not an RF hazard. You have to go through training for all these areas. So there's electrostatic discharge training, because you want to avoid generating static electricity, because that can damage equipment, or worst case can set off pyrotechnics. And then you also have to go through a number of other safety training procedures, and you have to redo those to get into that facility where the rocket's loaded. I think you have to get retrained every 6 months. But yeah, so you do have to be really careful to make sure that, because we're so used to carrying your car keys around, right? But you don't want those car keys in there, because there's a radio transmitter in those things. Your cell phone, how often do you just carry that wherever you go? Probably some places that you shouldn't carry it. And those have powerful radio transmitters in them. So there is a lot of retraining you have to do to make sure that you're RF safe when you're operating in these environments. Yeah. Anything else? I think back to you, Mark.
Yes, fabulous, and spot on
Thanks,
time.
folks.
Thanks, Will.
One more. Sorry, I wasn't fast enough. Will, do they totally evacuate Kwajalein when they're doing launches towards there? Will, you're muted.
Will, I think you're muted. There you go.
Hey.
And you're muted again.
It takes a second after you click it.
Okay, how's that?
Yep.
Okay, all right. Sorry about that, folks. So when you're flying stuff out of Kwajalein, what they do is the airplane flies either north or south. It depends on what orbit you want to get into. New Star wanted to be in an equatorial orbit because they didn't want to fly through the South Atlantic anomaly, those radiation belts. So for that, they flew south. But then there are some populated islands to the east, and so you have to sort of thread the rocket's flight in between those islands. So there's a lot of range safety stuff you have to do, but that downrange stuff from Kwajalein, they don't do any evacuations.
I was really talking about when Vandenberg does test launches towards Kwajalein. I was on the launching end. I always wondered what they did at the receiving end.
Yeah, I was always upset that they wouldn't. So I've done a number of trips to Kwajalein now, and I had always wanted to be down there when they did one of those flights, and they never let civilians like us be there. And part of that is because so many people from the test team need to be down there, and there are very limited resources on Kwajalein for just hotel rooms and things like that for just keeping people. So no, as far as I know, they don't have any of the family members, for example, go off island.
Okay. I guess they just pray.
Well, this stuff is pretty, I mean, it's not like there are any weapons on this stuff, but there is a lot of kinetic energy involved. And if one of those things hit, it would be bad. But on the other hand, the aim is really, really good. So I guess there's probably relatively little risk. But not having been on the island during any of those actual campaigns, I don't know if people are huddled in basements or if they're out, watching. I know I would be out watching if I could, but
too, absolutely.
Yeah.
Best Earth you could see.
Yeah, and I have.
Oh, sorry, I've just chopped you, Will.
Oh, no worries. I'm sorry, Mark. I was just going to say, I didn't get a chance to see either New Star or Icon, the actual flight, because I was stuck on a console inside a building, and I had people the next day say, "Oh, I saw that launch. It was so cool. Did you get to see it?" And I had to avoid slapping them. It was really, yeah. Anyway, thanks very much, folks. I'll stick around later for questions.
Thank you, Will. That was excellent. Very interesting. And nice to see a 16 being used in a very unusual situation.